Hello everyone and welcome to the Cisco Community Live event on getting to know Cisco SD-WAN. Hello once again. So my name is Hilda Arteaga and I am a community manager of the Cisco community and the host of today's event. So before we start, I would like to let you know that this community is an online forum with over 500,000 members where you can get answers to your technical questions prior to opening cases with attack. Also, you can answer to other people's questions or you can contribute with documents, videos, or blogs, and as well, rate the ones that you find good. And we're very happy that you are joining us today. As you might know, this is the last event that we are going to have this year, and this is quite an honor that we are collaborating with great experts. We are going to talk about how we get to know Cisco SD-WAN, which is very close to all the digital world. This event is going to be held by Cisco VIP and Cisco champion David Peñaloza and by Cisco experts Juan Rangel and Juan Flores. Since we have two Juans on this event, I will be referring to Juan Rangel as Charlie, and we'll provide more details, all right? So before we keep going on, there are a couple of news and events that I would like to share with all of you around the community. So first of all, we have an Ask Me Anything session following this event. This is a forum session where you can actually place all the questions that you have related to SD-WAN and all the topics that these experts are going to present here. Actually, if you have a question just right now, you can place it down there if you have too many questions or just here in the session. And we already have some queries from people who has been answered or are being covering. So let's say that if 1 hour after this event or maybe one day or a couple of days after you have questions regarding this topic, then please feel free to place them all and we will allocate the answer just right there. Also, we don't have the time to provide the answer during this live session. You will be finding the answer just in this Ask Me Anything event. The link to access to this session is going to be available on the chat, so you can have a look just right there. And also, I would like to invite you to one special event. It's also the last Ask Me Anything of the year. This forum event is going to talk about the configuration, the verification, and all the troubleshooting best practices of the dynamic routing protocols. So we are talking about BGP, ERGB, OSPF, ISIS. So all the questions that you have related to them, Elvin Arias will be answering all of these questions till Friday, the 20th of December. And well, since the year is finishing, Christmas coming, and the New Year's is right on the next corner, we would like to invite you to a special program that we have. We are trying to help the community. We are doing some lending a hand, actually, to Doctors Without Borders, so we can help out all people who needs medical aid around the world. It's very simple. When you help out the community, we help out other people who is in need to make this work better. So please, you can find more details. So we invite you to collaborate here and get things better around the world. All the details will be available on the chat as well. Well, we would like to invite you to become a top contributor. Remember that for that, you can help out to answer questions, write documents, also posting some videos, blogs, anything else that you need, so you can become a top contributor. Every month, we recognize people who is doing a great job. And as well, remember that everything that you find on the community, please let us know that it's useful for you, it's helpful actually, and provide a helpful vote if someone give you a right answer or if someone provide you well details. For instance, if you find this presentation quite well or this event, you can actually provide a helpful vote to the event page or to the slides of this event. And if someone gives you a right answer, you can accept it as a solution. This helps us not only to recognize the quality content in the community, but also to encourage more people to participate. And well, so to get started, because we have a very interesting and complete session, I would like to talk to you about the great expert that we have. Firstly, we'll go with David Peñaloza. He works as a senior, well, actually a lead network consulting engineer at Verizon Enterprise Solutions in the Czech Republic. Previously, he worked as a network support specialist in IBM Client Innovation Center in Czech Republic as well. And David is an expert interested in all topics related to networks. However, his mainly focus is on data centers, enterprise networks, and network design, including software-defined networking, which is well known as SDN. David has a long relationship with Cisco, and he has been a Cisco instructor for the Cisco Academy. He was recognized as a Cisco champion and designated VIP from years 2017 till this year, 2019, and most probably the next year as well. David holds a CCNP in routing and switching and CCDP, CCNA security, CCNA cyber ops, and CCNA in service providing. He's pursuing CCDE and other exams as well. Welcome, David, to this event, and thank you so much for being with us today.
Thanks a lot for the long introduction.
That's because you have a long career. All right. So next, I would like to introduce you to Juan Flores. He's a technical consulting engineer on the software-defined WAN team at the Cisco Customer Experience Center. Before he joined this team, he worked on the routing protocols team. He specializes on routing protocols, service provider technologies like MPLS, switching, Nexus administration with routing protocols, and SD-WAN technology. He holds a degree in computer systems engineer from the University of the Valley of Mexico, and he holds a CCNA in routing and switching, and he's pursuing a CCA certification. Welcome, Juan Flores, to this event, and we hope you enjoy it a lot. So as I was mentioning to you before, we have two experts called Juan. So here we have Juan Rangel. I'm going to call him Charlie so we don't have many confusions about the names. And he's a technical consulting engineer at the software-defined WAN team at the Customer Experience Center as well. Before he joined this team, he worked on the routing protocols team. He has 9 years of experience in networking and has deep knowledge of American Mobile International Network. Before he joined Cisco, he worked at Telmex, Huawei, and Citibank. He holds a degree in computer systems engineer from the University of the Americas in Mexico, and Juan holds a CCNP in security, CCNP service provider certifications, a Huawei ACDA certification and IWAN version 3 foundation, and a CCA in routing and switching. He likes languages, and actually he's very fluent in Spanish, English, Portuguese, and I think he's getting better in other language as well. Welcome, Charlie, and thank you so much for joining to this event. All right. So finally, if you would like to have a look, deeper look to everything that they are going to provide during this session and all the slides are available in the community. You can find the link on the chat so you can check them all. Remember that you can submit your questions at all time during this event. Please use the Q&A panel so we can help you guys to allocate all the questions. You can also use the chat, but that one we rather prefer to use it for logistic issues such as my screen got freeze, or I have audio issues, or I want to contact, I don't know, David or Juan or Charlie. All right. Well, thank you very much. So what I'm going to do right now is I'm going to give the microphone and the presenters role to Charlie, Juan Rangel, so he can start the session. And thank you so much for joining to this last event of the year, and we hope you learn a lot.
Okay, thanks, Hilda. Hey, everyone, thanks a lot for joining into this session for SD-WAN. That it's going to be really amazing, because what we are going to do is we're going to share the content, the basics, and also we're going to start with interesting topics that maybe you will like. Okay, so let me share my screen. Okay, let's start with this amazing session. Okay, so here in the description, so in this session, you will have the knowledge about the historical roots and the diverse behind SD-WAN. So this is going to be very amazing, because we're going to talk about the evolution of the networks. So most of you maybe are asking yourself, okay, so at the beginning, a couple of years ago, we were working with, for example, MPLS, frame relay. Like I remember when I did my first, my CCNA, so I had to study frame relay. So we're going to talk about how the networks, the evolution. Okay, so let's get started with the topics that we have. Okay, so this is the agenda. We have the evolution, the traditional WAN to SD-WAN, so the evolution of the protocols, the current solutions that you have with the service provider. We're going to talk about the network simplification, why we need SD-WAN, the next architecture, how does the overlay work, the planes of the SD-WAN, and at the end we have something special for you. We have a live demo in order to show you how SD-WAN works, okay? So if you are ready, I'm also ready. Before we start, so we have the first polling question for you. So if you can help us to answer here in the WebEx. So have you heard before about SD-WAN? If you have knowledge about SD-WAN, you can answer yes or no. There's no problem, because in here what we would like to do it's validate if you know this solution. Okay. Okay, so let's start with the first topic on the agenda. Okay, so the evolution of to SD-WAN. So let's talk about the networks. Over the years, customers are looking a new way in order to communicate different sites. For example, from one country to a different country. So for this, we need to do a segmentation of the network. So let's start with the beginning. Okay. So in here, we have at the beginning a couple of protocols. For example, we have BGP. BGP, it's really common. It's an open standard. Another technology that we have is MPLS layer 3. It's really interesting. MPLS layer 2. As you remember, in layer 2 we can use X-Connect. We have EIRP protocol that it's a Cisco proprietary. We have OSPF, an open standard, and also we have another solutions like DMVPN that it was really interesting, but here in Cisco it was created IWAN, performance routing. So I'm going to talk about a little bit of these protocols in order to understand why we need SD-WAN and what is the real benefit of having a software-defined WAN, okay? Okay, first of all, so we have a couple of network components in order to share data, voice, and video. So in here, I added a couple of devices. For example, you know, the router, it's layer 3. We have switches, layer 2. And we have different kinds of, for example, we can have a PBX for voice. We can have a telepresence system. But what happened with all of this data? So the devices need to collect the data, apply different policies. For example, if it's voice, video, we need to apply a QoS configuration and share all the traffic to a different site, okay? So now let's talk about a little bit of what is a LAN network and a WAN network. Okay, a LAN network. What we have in a LAN network? Okay, so it is, for example, we have, it is recommended to have this design, to have these three layers: the core, distribution, and access. Okay, core is the layer that is going to be connected to the service provider. Distribution, and in most of the cases we have powerful switches that handle layer 2, and layer 3. Okay, and we have the access switches that in here we need to connect the end devices. So this is just an example. So what we're going to do in layer 2, it's to have the different VLANs, so we can have for example, data, voice, and video as an example in here at the bottom. Okay, so what's happening here? So first we need to run a couple of IGP protocols, interior gateway protocols, that are going to route the traffic inside the LAN. Okay, so in here we can apply different policies. We can select one path that is going to be the preferred one, or another is going to be the backup. Okay, so in here we can use for example, RIP version 1 that, well, I'm not going to say that it's not in use, because in my own experience over the years I have seen some customers that still using RIP. RIP is very, very interesting, but for this, if we would like to have more benefits, we can use RIP version 2. EIRP, OSPF, and ISIS. Okay, so basically we need to have protocols in order to route between different subnets, and then it's coming the traffic to the default gateway. Okay, so now let's go to the second part. Okay, now we have the WAN network. What is a WAN network? So for example, in here, if we would like to communicate Chicago to Dallas, what we have here, we need to run a protocol, an IGP protocol that is going to have all the routes, what is the best path, if we are going to apply any policy. But if we would like to advertise all the routes to a different location, we need to have a connection to the WAN network. So basically, for example, in a common scenario that we are running a BGP on the C device, this is the customer edge device, we need to have, for example, an autonomous system. So there's a difference on the autonomous systems, because we can have private and public autonomous system. For example, I'm going to ask you a question. If we would like to configure an autonomous system in the LAN site, what autonomous system do we need to add? So the answer is we need to use a public autonomous system, because the private autonomous system, those numbers needs to be unique on the service provider, okay? So what happened here? So basically we advertise the routes to the service provider. The service provider receives those routes and send again to the other location, okay? So now let's talk about the current technologies that we use to advertise the routes, okay? So we have, this is just an example for the current technology with MPLS. So the idea is just to have an external BGP connection with the provider edge. The packets coming here needs to go to the provider devices that are here with the capital letter P, and then needs to go to the provider edge device, and finally goes to the final destination. Okay, the normal operation of this MPLS layer 3 network, it's the following. So the idea was to send the traffic using layer 2 here on the MPLS network. And how we accomplish this behavior is because, for example, we send the packet, and MPLS, the operation of MPLS, we need to have 3 operations: push, swap, and pop. So push is when we are going to add a specific label. So maybe we can add a label number 1. The packet comes here to the first provider router. Then we swap to, for example, label number 2. In here on the second provider, we swap again another label, and finally on the provider edge device, pop the label, basically removes the label and sends to the customer edge device, okay? This is a really good solution. What is the benefit of this? Because on the MPLS, the provider edge can use VRF, virtual routing forwarding, that it's a unique routing table for each customer. So I am saying that this provider edge can have multiple customer edge devices from different customers, and for inside the MPLS we need to run a route reflector. The idea of the route reflector is to avoid using multiple internal BGP connections to all devices, okay? This is a really great solution, but again, what is the big problem of this design of this solution? It's very, very expensive, okay? So what happened over the years? So the customers they wanted another solution, okay? So then came this solution, for example, DMVPN network. What is the DMVPN? The DMVPN, it's a connection that we need to have and use internet cloud. So what is the difference between the Internet Cloud and MPLS, that the Internet it's only better for traffic. The MPLS network, we can have virtual routing forwarding, we can apply a quality of service, so I mean the service it's better. But with the DMVPN network, one idea was to use multiple GRE tunnels in order to have connections between the spoke devices towards the hub, and in here it was we have a couple of components of the DMVPN. So, for example, if it's an internet connection, so it is insecure, so it is necessary to add on the GRE tunnel IPsec. Okay, IPsec for what? In order to encrypt all the traffic. Okay, quality of service, we can use also dynamic routing. For example, we can use EIRP, OSPF, and we have a couple of phases, phase number 1, 2, and 3. So, for example, at this moment, it is really recommended to use phase number 3. Why? Because phase number 3 can help us to have tunnels directly connected between the spokes devices, and it's not necessary to go to send the packet. Imagine from this spoke going to the hub, and the hub, okay, send to another spoke. So this is a waste of bandwidth. Okay. After this design, it came another technology. Okay. The next technology it's IWAN. So, what is IWAN? PFR. So, at this moment, a lot of customers are still using this great solution. It is, I'm going to step back in here. So, it is basically the same design, but just remember this slide, DMVPN network, we use internet connection, and on this, what is the difference? Okay, so first I'm going to talk about the components for IWAN. So for IWAN, we need to have master controller, this is going to be the brain of the IWAN domain, the PFR domain. We need a transit hub that is going to be like the backup of the master controller, border routers, and for example, we need to have the branch routers that are basically the spokes. On this solution, it is necessary to run IOSXE, for example, ISR 4K, ISR 1K, okay? So what is the behavior for IWAN? So basically, the traffic, the hub master controller, sorry, it is the brain, and in here we can apply the policies, we can apply, for example, mark a specific routing with the different QoS values, well, the DSCP, if it is critical data with the DSCP AF 31, 32, 33, if it is voice traffic with express forwarding. So basically, this guy, it's the one that is taking all the decision on the network. So in here, we're going to send the traffic to the border devices that are connected to the MPLS or iNet cloud, and the idea is to, for example, if you have critical data, okay, it needs to have the primary path going to the MPLS. And if the SLA or if we're not receiving smart proofs are like the keep alive on BGP. If we are losing smart proofs, so we're going to switch the traffic to the backup, that it's internet. This is one of the main advantages of IWAN over DMVPN, because this is intelligent routing here. So as you saw on the previous slides, we started with the LAN, with the WAN side, with the MPLS, DMVPN solution. DMVPN it's not dynamic, so IWAN it's dynamic. And this is just a summary of the evolution that we have on the networks. Okay, so now let's go to the magic. Okay, before go to the talk about SD-WAN, so we have another polling question for you. Okay, so which solution do you currently use in your network? So we have MPLS layer 3, MPLS layer 2, frame relay, or IWAN. Okay, if you can help us to fill in to put your answer on the on the WebEx. Okay, and now network simplification. Why SD-WAN? Remember, SD-WAN is software-defined WAN. Okay, this is the magic. Okay, in SD-WAN we have a couple of challenge. Okay, so we need to accomplish efficiency, experience, and security. Okay, we need to be able to handle multiple transport sites. Okay, so the experience for the end customer needs to be the best of the networking, because in here what we are looking for with SD-WAN is to have to make everything more simpler to the end user. For example, if the end user would like to receive traffic information, or if, for example, if we would like to configure a couple of devices, so in previous sessions, so for example, we need to go to only one physical device. Just remember this, because we're going. On the previous technologies, we had a physical device, but in SD-WAN it is much simpler. Okay, and for sure, security, that is the most important thing here. Okay. So for SD-WAN, we have also three other features. So we need to capture the business objects, centrally define and active policies. That this is really important, and assurance, constant visibility into the network in order to validate what is occurring. Okay, why I need to change a specific policy, why I need to, for example, to send a specific traffic to a couple of devices. And just remember this, the difference here, because we have two types of devices. Cisco devices are CH device, and Vistela devices are VH devices. Okay, so talking about with this explanation of how the networking has been growing. Okay, we can start with the magic. Okay, we have another polling question: do we need physical hardware for SD-WAN? If you think that we need physical hardware, you can answer yes or no, because in the next slides, my colleague David is going to provide you more details about the architecture of SD-WAN. Okay. And remember, at the end, we have a live demo that this is going to be something special for you.
Awesome. Then thank you very much. Okay, thanks for Juan for giving an introduction. And now we'll cover exactly what do we mean with all this evolution of the SD-WAN. What's really the architecture, and in which way this is providing an intelligent forwarding decision, and what are all these elements interacting to make this possible. Let's just get back a little bit to the evolution, just because we need to understand which problem we are trying to solve. What are our WAN requirements? The customers require that our WAN solutions provide visibility and analytics. The customer requires to be able to see what happens with the applications, if they are delivered, if the traffic is delivered in a timely manner, what exactly is happening with my traffic, if it's handled properly, if I need to improve it, if I can get data from the behavior of my devices. The main point of this towards the optimization, if I can see that there is a specific behavior in my WAN network, then I can try to find a way to fix it, to improve it, to get it better. That's the main point, to not only be able to see it, but also learn from the data, unlocking the power of the data. Our next requirement is the consistent security. We must guarantee that the data is properly secure. We have regulations to follow, HIPAA, or the credit card, the regulation, apologies, I don't remember the acronym, or GDPR. So the main point is to guarantee that all my data in motion being transferred between point A and point B will be correctly protected, will be correctly put into, behind this let's say, behind these protections that solution can provide. And this is only for the data being sent. We also need to cover the data that all the devices will exchange to make sure that my network is able to forward all the traffic. So we're talking not only about customer data, but also our data as an infrastructure. How do we keep the network alive? All this data, all this information needs to be kept secure, needs to be kept protected. Our next requirement is the deterministic app performance. One of the main requirements actually is that the customer needs to know which one is the best way to treat the information that will be delivered so their applications might work. Which means that if the customer decides to send specific data through a specific link because it provides them with priority service, then they can make this choice and leave all the other data out of it. It doesn't mean that it cannot be done with the current solutions, being non-SD-WAN, but it means that this is one of the requirements that we are trying to fulfill with this new solution. Also, it's one of the ways we just step ahead. We just provide an added value to the customer because this is provided in a not so complicated way. You don't need to think of many complex ways to do it because, well, in the way that it is presented to the customer will allow the customer to just do it in a, well, simpler manner. The application bandwidth. If we compare SD-WAN with a previous solution, one of the selling points of SD-WAN, or one of the important points, is to augment your bandwidth in transit using internet-bound connections. Not all the traffic you will be transferring between point A and point B on your network would need priority treatment. Not everything will be voice or video. You might have traffic which is only file transfers. You might have traffic which is only email or web browsing. Do you need all the traffic to be priority treated? Probably not, and that's why you have tools like QoS. You give the preferential treatment to whatever you need to be preferential. Other than that will just be treated as a default. What we do with SD-WAN is we allow then the customer to augment all this bandwidth and make use of all other transfers not being MPLS to reduce the cost and at the same time increase the bandwidth available. The rapid time to capability refers to the capacity of making quick changes in a swift manner, just to make sure that we are the first one to get there. Making changing, allowing us to apologies, to deliver the best value to our customers in a timely manner. I don't need to go through a complicated change management process with my supplier and that supplier with another supplier if part of the infrastructure is managed by other parties. If it's under my management as a customer, I simply can go and make the change I need, and tomorrow night or maybe in 2 days it will be done. There's a difference here between relying on other suppliers and just handling your SD-WAN solution on your own. You have all the power to just get there and make the changes as fast as possible to provide to your customer the value you need in the timely manner you just wish it to be. And as a last requirement, we would need a cloud-ready architecture. Why do we need a cloud-ready architecture? Because the current requirements in nowadays is that the workloads can be moved to the cloud. We want availability. We want regional access. We want everything all the time available and fast and ready for us. And this is what the cloud provides, this ubiquitous distribution of all the information that we need from any part of the world. All the companies moving their workloads from a private cloud to a public cloud, they are doing it for, well, not only the availability, but also the cost, but also the regional availability if it's not a global provider, as an example. So all of these are reasons for the companies to simply try to move the workloads to the cloud to make sure that, well, we are simply not left behind. The cloud has become an important part of all our businesses. If our networks are not ready to use it, then they wouldn't be meeting these requirements. So what do we do with SD-WAN and all these requirements? We simply put all the pieces together and provide the customer with what they need. Anything they need right now to build the networks of the future. Now, in the SD-WAN architecture, we have 4 different devices or 4 different elements that will provide most of our services. These elements are vManage, vBond, vSmart, and Edge, on the Edge router, previously called as VH, before the acquisition. So what is actually each one of them doing? What exactly is their function? vManage will allow us to create policies. It allows us to have troubleshooting tools. It will show us the outputs from those devices. We can even access the devices straight from the controller, from vManage. We can just check how the device is performing and get all the intelligence we need. What is the CPU usage of the device in the last 3 months? What is the memory use in the last 3 weeks? How many processes are running on the box? What are the events? What are my log entries? We'll get all the information we need from all the devices from a centralized station. And on top of that, vManage allows you to interact with it using programmatic interfaces. So not only a web GUI, you can have an API. You can have any kind of interactions that allow you to use these programmatic interfaces, so the API will get back to you with the information you need. Vbond would operate in something we call the orchestration plane. It will be our first point of authentication. Each one of the devices in the network will first get to Vbond and will authenticate itself saying, hey, I belong to this network. And Vbond will say, okay, let me just check your certificate. Show me your company name. Show me which organization you belong to. Let me see your device ID. What's your IP address? What's your host name? Prove me your identity. This is what Vbond will help us to achieve. In which way this becomes important to us? Because you don't need to do any manual change in other point of the network. You provide the device with the configuration you need and boom, it's onboarded. And on top of that, Vbond also will allow us to use it as a it facilitates not traversal because we would use it as a STUN server. We'll clarify what is a STUN in the next slide. Now, coming to our third point, vSmart will handle all the routing happening in my network. It's our main brain. If you have a little bit of knowledge about the BGP, then you would remember a route reflector. And SD-WAN vSmart controller would work as a route reflector. It will allow us to see what are the possible paths my network can offer and what is the VPN membership between several of the edge devices. On top of that, it would allow us to facilitate encryption between the edge routers. The edge routers would handle certificates and would need encryption keys to establish secure channels between them, and vSmart will redistribute, or actually will distribute, not redistribute, apologies, all these keys into the control plane of the network, providing to all the devices in my network the capabilities to encrypt the traffic and to provide us a secure overlay. The last item of our 4 bulk devices here is the edge router. The edge router will secure the data plane with other VH routers. VH or CH, apologies. What it will do, all my data plane information, all my customer information will be simply encrypted and protected when it comes from point A to point B. And this is thanks to all the other elements in the network, allowing the edge router to get all the information needed. Who's my next hub? Where should I send this information? What's the encryption key? Who's the other guy on the other side? These are the kind of questions that the edge router is asking, and as an answer for those questions, it would have a policy, and a policy will be just a set of actions applied to the information we need. Now, talking about components, because we already discussed what are all these devices and what they do, but if I show you something like this, you would say, whoa, hey. This is a little bit complicated. There are too many things in this diagram. Let's just chop it in pieces. How do you eat a big elephant? Just piece by piece. So let's just go step by step on all these elements. How does my underlay look? My underlay would look as we can see right now. I have a couple of providers being the provider on the top, allowing me to use the internet, and provider on the bottom, providing me, apologies for the redundancy, providing me MPLS services. Now, what occurs with the underlay? So far, it's simple. So far, we have our transport, we have the edge devices, and we have our connection to the cloud. So what occurs if we keep building it on top? Let's just add what we will need in our underlay so we can onboard devices on the overlay. So let's get the controllers now. Now it gets a little bit more complicated. Note that the controllers have appeared, not only the edge devices, but also our Vbond is here, vSmart on the top, and vManage on the top left. So my panorama is getting a little bit more complicated. All the landscape is growing, but this will be simply something that we'll see on the underlay. So what is the main point of this? To understand that even though a solution might look simple, it would have many complex inner moving parts inside of it. And this is abstracted so the user cannot see it. It doesn't mean it's not there. The complexity doesn't disappear. It's simply not shown to the user because it will be overwhelming. Now, after I add all my controllers and I authorize all these devices to onboard and the overlay, then I simply just get completely abstracted from it, which means that we wouldn't see the underlay. So what occurs if we don't see the underlay? How does the overlay look? It looks as it is. So this way, we would see that on my overlay, I would have my edge devices, I would have an IPsec tunnel between them running BFD to test the liveliness of my links, and I would have control connections that would run from the VH devices towards the controllers. Please note that the control connections are not between the edge devices, only from the edge devices towards the controllers. Why do we use TLS and DTLS? We protect our control plane. The fabric is supposed to be as secure as we want it to be, which means that all these control connections will be protected using TLS and DTLS, and inside those DTLS and TLS tunnels, and I would have a control connection using OMP, Overlay Management Protocol, our control plane protocol to manage my overlay. Why VFD? Because if we are using the underlay as our transport, we need to guarantee that actually the underlay is providing us with all the services we need, which means that we need to test the liveliness of the link. We need to test the delay, the jitter. If there is packet loss, what do we do with it? Well, we simply make use of BFD because it's a lightweight protocol. It allows us to then be able to test all the way end-to-end from one point to another point, and then decide if this is the right way to transform my applications, if this is good enough. The same way we would do it with IPSLA with our providers. But we use BFD for it. It's more immediate. It's faster. It allows us to test much more. Now, in which way can we actually deploy all this? Well, it depends on the devices you would be deploying. If we're talking about edge devices, then you can just deploy an ISR router, ISR or ASR, running iOS XC with Viptela iOS on top, or you can have the devices that were offered previous to the Viptela acquisition, VF100, VF1000 or 2000, or even VH5000. These are modular devices, and you can simply add another line card or another new accessory to it. But what if you're talking about my controllers? My controllers are purely VMs. My controllers are not physical devices, which means that I can run my controllers using any sort of virtualization in my private cloud, being my data center, or I can run them in the public cloud. It could be in Amazon, in Azure, or any other major cloud provider. We make use of not only the hardware, but also the software to deploy our controllers and also our edge devices. My edge devices can be also a VM. My controllers will be virtual machines, and on top of that, my VH cloud, which is the name for a virtual machine running Viptela SD-WAN. Cisco SD-WAN or Viptela, apologies. They will be called VH Cloud. This is another, let's say, model for our VH devices or our edge devices, but only for virtual environments. So, as explained earlier, then we have a wide range of possibilities in which we can make use of our hardware or even software. Now, what exactly are the benefits of all of it? We have been talking about what we can do and how the magic occurs and who talks to whom, but what are these benefits? Well, I will get, as mentioned before, I will get my infrastructure ready to have cloud delivery, to have information about how everything performs, to have security built in, to be completely agnostic of my transit. I can have any kind of transit of transport under it, being even LTE, or MPLS or internet, but on top of that, I will have my overlay built, and once my overlay is built, I completely get the abstraction from all these underlay. It's agnostic. I would also have the possibility to monitor how my applications would perform and how my users would perceive it using the proofs by BFD. So the quality of experience is a factor that I would count in to understand if my policies are correctly in place or not. If my applications need a little bit of help from the network on top of what they have right now, or if we need to make any change in the policy, so we accommodate for some growth, so we accommodate for some unexpected traffic bursts or similar situations. The visibility is what we use to make a continuous interaction and to grow, to improve, to deliver a better service. And as a last point, I mentioned in the previous slide, but we have flexibility for all these devices, being, as mentioned earlier, my edge device, a possibility to be a hardware device, but also to be a cloud device, to be anything based on virtualization. The same applies to my controllers. Actually, my controllers are only virtual devices. So we've mentioned many things, and I'm sorry, I know I talk a lot. We've mentioned many things about the solution. It could be hardware, it could be software. We have communication between several of the elements, being vSmart, Vbond, vEdge, and vManage. But we now need to talk about what is the important difference between our current traffic flow and our current solutions and the previous ones. Why is this important to make this point? We'll see about it. First of all, we are used to see that our traffic is simply going through the same box all the time, which means that my router will always handle data plane, control plane, management plane, all the planes. But what exactly are these planes and why we need to understand each one of them? Because in regular networking, all of them are in the same box. There is a bundling of all these planes. But in SDN networks, all the planes are separated. So now we have to then digest the fact that these are planes that work separated, and the fact that they are separated will allows us to understand which one of the functions they are providing to the network. The first of these planes is the control plane. Control plane is any kind of traffic that is being shared between devices and keeps my network alive. A BGP advertisement, an OSPF routing update, an EIGRP query message, or an EIGRP query reply message, or simply the multicast communication between two HSRP gateways or VRIP gateways. So as simple as keeping my gateway up, or as complex as implementing a conditional forwarding policy using BGP, conditional announcement. All of this is control plane. It keeps my network alive so I can send the packets through it or over it. Which leads us to the second of the points. What's my data plane? My data plane is all the information I can send from point A to point B without considering the control plane. So this is the information that belongs to my customer. Emails, bills, or anything my customer is using, phone calls or video, Java, WebEx, anything my customer is using thanks to the architecture and to the infrastructure I am providing as a provider. So assuming there is a provider offering MPLS services, then the control plane they keep is what keeps the MPLS network alive: BGP, LDP, RSVP, TE, inter-AS, and all these functionalities. So the reachability exists between 2 points in the network. But once that reachability is there, then okay, now we can make use of it. That's where the data plane comes in. We use all these infrastructure built as our highway. So we have a highway to go from point A to point B, and that highway is being used by my data plane. Now, what's a management plane? The management plane is what we would use, or the type of traffic that would keep my devices monitored, that would keep me information about them. Is my CPU okay? Is my infrastructure working well? How's the fan? How's the the memory usage. How many logs do you have? Hey, is your bandwidth enough? How are the counters of the interfaces? All this information is being communicated through the well, in this case, it would be SNMP. It could be an API call, depending on the solution. But this would be management plane. So please note that all of them are completely separated planes, and we are used to have them in the same box. We're used to have them where? Well, we're used to have them in the same router. So the same router will get the SNMP proofs, would have the SNMP, we would run the SNMP walkabout against it. It will have the syslog servers configured. It will make the redistribution possible, and on top of that, will forward all the information. We are used to see everything on one single box. This doesn't occur with SD-WAN or with any SDN solution. All the planes are separated, and the functions belong to specific devices. Who is managing all these planes? The controllers. The controllers are this decentralized point where I would deposit all this information, where we would keep all the information. For which purpose? Depending on the plane they work on. So if we talk about vSmart, vSmart will be the main repository for my control plane. It will keep all the routing updates. It will keep all the prefixes that we can reach. And in which plane would work vManage? On the management plane, it will have information about all my devices. It will provide me with intelligence about what is occurring in my network, which application am I recognizing, what's your bandwidth in the interfaces. Can I run a packet capture? Can I run troubleshooting? All of this occurs in the management plane. It's not drawn here, where my other element would be the VH, and it will be on my data plane. We'll simply forward the data from point A to point B and apply a policy that it's suit to my data, being QoS policy, application aware routing, access list, or anything I would apply on that information so I can make sure that the delivery is timely and correct. Okay, now putting it all together, let's just provide a quick overview of what occurs when the onboarding happens. On top, I have my control center in my blue rectangle, and under it, I would have the two VHs and my transport. So assuming all my information is there, or all the connectivity is in place, what occurs when the VH communicates with all the other devices? What exactly is the cycle? What's the process? Well, let's start one by one. If my VH on the right, it's getting onboarded in my network, what would occur? It would communicate with Vbond. Vbond will check a list it will have, and then, hey, VH, blah, 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 and your serial number is here, and this is your IP address, this is your organization name. Yep, you're good to go. Good. So as the Vbond will have the information for all the devices, at least for IP addresses, then it will send them back to him. Hey, this is your vManage and this is your Vbond. Communicate, your vSmart. So communicate with them. What would the VH do? Well, let me just follow instructions. I would just communicate with my vSmart here and with my vManage this way. What would each one of those devices provide to us? The vManage will check, okay, so this is your certificate. That's awesome. I'll have a dashboard. So my dashboard will have several panes here. I will have a graphic or my bandwidth and historical information. Anything I would see on my dashboard, and it will push back some configuration to the box. Hey, use this template. This is what you would need. The device will just get all the information and say, good. So now I have everything configured. What's next? Your next information will come from your vSmart, the controller providing you with the routing tables and all the policies. So then it will communicate with vSmart, and vSmart will simply tell, hey, dude, this is your next hop because I have here my list, and these are the networks you want to get to. So, well, let's just communicate over OMP, and I will send everything back to you. So now the router on the right will have all the information it needs, policies, IP addresses, prefixes, and next hops. But who's my next hop? This guy here. So now that I have my next hop, I can now use all the information I got through the control plane to establish a data plane tunnel, my IPsec tunnel using BFD. So see, I had to communicate with other three devices, get onboarded on the SD-WAN cloud, get the configuration from vManage, and then get all the policies and routing information being my control plane for vSmart, so I could finally just, well, bring up this tunnel using the data plane so I can communicate with the other VH. Looks simple, huh? It can be complicated, but thanks to the orchestration plane we run on Vbond, this information is almost not seen by the user. Once you just put the serial number as you authorize it, boom, all the information is there. Now, let's talk quickly about the SD-WAN lingo. We have some interesting topics or interesting terms that might seem complicated, but they are actually very similar to what we have seen till now using a VGP. Okay, so overlay management protocol is my first actually topic here. And which one is this one? This is our control plane protocol. This is the guy who is holding all the information and vSmarts, because the vSmarts will keep all the information with it, and then the overlay management protocol will be the way to keep this information and also to share it. I would use a control plane protocol so I can distribute not only routing information, but policies and encryption keys, and I would be the main brain here running everything. Transport locator. It's a fancy name for something as simple as a next hop. So if you remember the VGP lingo, then you will get back to I have my network and I have my next hub, and boom, that's all I need. Which one is my color? The color will allow the devices to understand to which transport they belong. If they belong to internet transport, if their configuration is based on MPLS transport, where am I? And once I know where am I and to which transport I belong, I would understand to where I should establish those tunnels, be it to internet or to MPLS or anywhere else. Site ID would be a simple identifier for each one of those devices. So site 1, 2, and 3, and each one of the sites will have a different. Well, if you have two devices in one site, they'll definitely will have the same site ID. But if they are devices on several type of locations, being one data center, one co-located data center, one small shop, one HQ, each one of them is a specific location. Therefore, they would have a specific site ID. Lastly, or one of the two last ones are my system IP. It's simply a unique identifier. This doesn't have to be routable. This is just an ID you give to your device. Now, one of the recommendations is to keep the same management IP as your system IP, simply to not make it that complicated, but it doesn't have to be a routable address. It's simply written in an IPv4 notation. So it will be a dotted decimal. And my organization name. My organization name is this information I would need to understand to whom this fabric belongs. Which one is the administrative domain I'm working on? Lastly, we have our VPN. I can have, I think it's 64 VPNs, and the VPNs would simply be another level of segmentation inside my secure tunnel. If I have several VPNs, all of them will be logically separated and identified by a label. And this label will allow me to simply keep them separated and transport them transparently over the network. Okay, so quickly for the Vbond. We have talked about the Vbond and all the power the guy has, because he is this dude waiting for everybody to authenticate and say, hey, I belong to the network. So, okay, it will say, show me your papers. It works in a whitelisting approach, which means that if there is no explicit allowance, it will not allow the device to onboard. How do we identify whom we are? We do it using a list of certificates. So vManage will have a list of certificates, and he will send all these certificates to the Vbond. What would be the case for this? The Vbond will have all the devices it needs to allow into the overlay. So if you're not allowed by vManage, I'm so sorry, dude, but you will not will be onboarded on my SD-WAN fabric. So why is this based on certificates? Because it allows us to not use pre-shared keys. We use a public and private key system, and this architecture allows then all devices to keep their private key, and then the public keys will be distributed between between all the edge devices using OMP. We use AS-256 to provide confidentiality, and SHA-1 and SHA-2 to ensure the integrity of the information we're sending over the transport. So how do we show the device's identity? In the hardware devices, there will be a chipset called SUDI. Well, it might or might not have it. It's a little chipset that will be installed during the manufacturing. This chipset is unique, and in the case of this chipset not working, then you will have simply to replace the device. You cannot replace the chipset. It is a unique way to identify each device. In the case of the software devices, you would have a certificate signed by vManage. So vManage will be your certificate authority and will be managing all your certificates. So who's the root for those? In the case of the controllers, their root for those certificates would be widely and publicly known certificate authorities, DigiCert or Symantec. And in the case of the hardware devices, then we would have Avnet and Cisco, the manufacturers of all the VHs. Lastly, for the VH clouds, these are just VMs. So who gets to put all the control on the VMs? Well, that's for vManage to keep an eye on. Every device, whenever getting into the overlay, would connect to Vbond. This not only applies to devices getting for the first time into the network. No. This applies to any device into the network after each reboot. Remember, we are based on a whitelisting approach. I need to confirm who you are every time you connect to the network. This is a secure approach in which I prevent my network for any, unwanted visitors. On top of that, Vbond is a STUN server. So some people will say, hey, what the hell is that? Well, a STUN stands for Session Traversal Utilities for NAT. What does it do? It sounds complicated. Well, it will just help you to solve one problem. So what exactly is this problem we are trying to solve? The solution was built to be intelligent. So you would see that many changes would take place, but they would be performed without the user interacting. It simply will do it by on its own. And one of the mechanisms that would allow the solution to be in this way intelligent would be STUN, because it will perform, or it will allow Vbond to keep a register of who is the VH, what's the public IP, the public port, the private IP, and the private port, and then allow all the VHs to communicate between them. Why? Because we can have devices behind NAT. And if you're in Asia, you have several layers of NAT because, we're still using IPv4. So if we have any kind of NAT, path, restricted NAT, or port filtering, this will be potentially detrimental to all the communication in the solution. For this reason, then, Vbond will just make sure that it understands which are the ports that we have in each one of the sites, and then the VH will know, hey, I need to communicate with this IP on this port. Why? Because Vbond told me, bam, you get to communicate on the other side. In this way, you guarantee that BFD, TLS, DTLS, and IPsec, who are individual elements of the solution, would allow it to, simply they will just work, allowing the solution to be completely or holistical, just to define it somehow. Okay, so as a last tip on the top, yes, an overlay will be limited up to a certain extent by all the policies on the underlay, but this is exactly what we have been talking here. Depending on the limitation of my underlay, my overlay might be also limited. So this is one of the ways to go over some of these limitations. So which kind of policies do we have? We have a couple of ways in which we can manipulate not only the information, but also the information being forwarded, but also how the planes communicate, how the routing occurs. So we would have a control policy or a data policy. My control policy would be any modification affecting routing behavior. So control plane purely. My peerings, if I have another router protocol, some prefix announcement, or if I'm tagging a prefix so that I can filter it later, I need to understand to which VPN this belongs. All of it belongs to the control plane. So anything on the control policy will, affect anything on the control plane. What about the data policy? Then any modification affecting data plane forwarding. So if I have packet markings, QoS markings, I need to define a specific transfer or application aware routing. If I want to to send specific applications to specific transports. And the policies can be provisioned in two ways. They can be centralized or they can be localized. The difference are that the policies might be pushed from vManage to vSmart and then down to all the V edges using OMP, or it can be provisioned directly from vManage to the V edge. Hey, this is your policy, bam. So that's the whole difference. So one of them is centralized, goes to vSmart. The other one is localized and goes directly to the edge device. As the last point, we have the templates. The templates are these, what we have been using till now in all our deployments. We have these huge, it can be a text file or it can be an Excel spreadsheet, and we have just a huge block of text and we just replace some of the information. The templates are exactly this, but they allow you to just replicate in a standardized configuration in a not so complicated manner. With the templates, you can have a huge configuration, or you can have several small pieces just fitting them together. It's like playing with Lego. The template types could be a feature template, which is just a block of configuration covering specific features. OSPF, SNMP, EIGRP is now supported, by the way, or VGP, or just specific features, not the whole configuration. And, well, think of them as this repository for all the config you need. So if you have a site that doesn't need OSPF, then you would just not use that section of the text. My device template is the way that I keep all my feature templates together. So it will be my bucket where I will throw all the feature templates and I will put them together. It allows the grouping of all these feature templates to be only one template per device. Some devices might not need all the features, so well, take only what you need. And similar to building towers with Lego, it's the same as building a device template. Take the colors you need: blue, green, yellow. Maybe in this deployment I don't need red because red means, I don't know, OSPF. So our last type of templates, my CLI template. The CLI template is actually analogous to what we know and love. This old school and effective text of information that we use to just copy paste into every one of those devices. It's as we know it. It's simply all the info in one chunk. So why am I telling you which one of these templates is each? Because the templates have some advantages that we can make use of. They have these variables. This is something we know as IP addresses and all this information that may change between each one of the sites because the IPs changes, the host name change, even the AS for VGP might change. And this is the information that you can change in the template. If nothing else would change, then you don't need to touch anything else in the template, only the information changes. This will relieve you from a lot of work, honestly. You don't need to touch things that you simply do not need. In each one of these templates, you can attach many VH devices. So if you make if you can modify the template, you will be modifying all the devices attached to it. They work in this parent and child type of logic. So once you modify the parent, all the childs attached to it will be modified. So use these in your advantage. If you have a specific configuration, just try to make out your sites predictable. Try to make all the design as similar and as standardized as possible. This will allow you to squeeze all the juice that all these templates will give to you. As a last point, and this is quite important, if there is a change in the configuration preventing an edge device from reaching its controller, from reaching vManage, then it will automatically roll back. It will say, hey dude, whatever you configure here doesn't work. I will just get back to the previously known configuration and you're done. It will help you to prevent these calls with your supplier and saying, hey, I need somebody on site with a console cable just ready to connect to my device, because it will simply roll back to your previously known configuration and, well, you will be safe. It doesn't mean that we can play matcha with it, but it's a safeguard mechanism. Okay, so it's demo time. Are you guys ready to check the demo? Juan, the ball is on your court now. Thanks everybody for your attention.
Thank you. Hello, everyone. Okay, so we're going to continue now with the live demo that we have for you about the SD-WAN solution. Let me share my screen. Okay, so what we have on the screen is the main website to enter into the vManage. As you know, we can manage pretty much everything of the SD-WAN overlay via this vManage. Okay, and then here we have the vManage dashboard. It's our main page, and we have a lot of information here, an overall information about the devices and what we have on our overlay. For example, we have here two vSmarts, how many VH we have or CHs we have here, vBonds, vManage, and we can easily monitor some things that can happen on the overlay. Such, for example, if we have a reboot, we can see that here, how many control connections we have up, partial connections or control down connections here, right? So, for example, if we have some kind of certificate errors here or warnings, we are going to see the counter here increasing, right? A very quick overall of what we have on the SD-WAN. So, for example, here the application aware routing, we have a percent for average loads, a jitter for the tunnel endpoints for every specific VH that we have on the network. If we have the application able, we will be able to see also some statistics about it, and well, some transport health statistics here as well. But okay, this is a quick overview of the vManage main dashboard, right? But let's go ahead and now go to another interesting part of this live demo. That, for example, here on the map, once you configure your device, you can set the GPS parameters of where your device is located, and then you're going to be able to see all your devices in the world. If you have a device in London, it will appear here, or in the US, or in Asia, it will appear here. So you can easily monitor all your network with this vManage dashboard. Then on this other tab, on the network tab here, we can monitor all our network from the vManage. We are going to have all our devices that are part of our overlay. Some of them here, for example, are reachable. Some of them cannot be reachable for some reason. And here we have the version of every specific device that we have on the overlay, right? The host name and the chassis number, and the type of device. For example, here the module is a VH Cloud and VH5K, and here, for example, is the vManage. But let's go ahead and check this VH Cloud that we have here. Here we can also monitor some parts of our device and and check pretty much everything on that is happening on the overlay with this device. For example, we can monitor some interface statistics, the transmit and receive traffic for this specific device for any given interface, Ethernet 0, GIG 00, or GIG 01, right? You can easily manage everything you want to see here. Let me go ahead and show you something else. As you know, we create some control connections with the controllers here. With this device has a control connection with the vManage, and we can see this control connection here in this drawing. If we go ahead and go to the some troubleshooting tools, we have here some tools that are going to help us to troubleshoot any problem in our network. For example, packet captures. You can easily set the VPN for in which VPN you want to take the capture, what interface, and you can configure the filter from any given source IP to any destination IP and set any ports. Right. Once you start the capture, you can download the pickup file and open that into Wireshark or any other application that you use to see the packet captures, right? You can also run some ping tests, trace routes to any particular destination, and even a speed test to monitor the speed of your link. In this section, in the real time, from the vManage, you can here, for example, you can see some system information parameters, the site ID, time zone, but you can also check other things here. For example, the routing table. For this device, you can establish a filter, but I'm not going to use any filter here. And you can see what a quick overview of the routing information base for this device. You can also establish a filter because, as you know, we used to have a lot of routes in our edge devices, right? But if we want to see what routes are received from OMP protocol, you can also see everything here. You have a lot of options here to monitor your device, going from app aware routing, BFD, BGP, cellular interfaces, CFLOD, it's a new version of NetFlow, control connections, DHCP, and etc. You have all these options to monitor your network in live, all centralized in the vManage. You can easily monitor your network, and you don't have to go to any specific device, and that makes the life easier for you. Here and this tab on the alarms, you can monitor all what events happened on the network: critical, major, medium, and minor events. For example, here we have critical events. BFD session went down, and if we go down, the control TLOC, went down for this entity, this internet link. This is for the site ID, and well, we have a medium events here. In other words, you can easily monitor everything here. Everything is going to be displayed in this particular section on the alarms. But you could also have some events. On the events tab, you have a critical, major, or minor events for this. For example, for the vManage, you have the severity here for the and some details of what happened to this device. A BH5K. This is the host name, the system IP of the device, the event name, control connection TLOC IP change. It's a minor event, and well, some details about this, right? You can you can see this event from the vManage, but also let me tell you that you can also see the same on the device's CLI, right? On the CLI, yes, you can see everything as well, or you can download what is known as the admin tag and find this event in the admin tag of this device to troubleshoot further any kind of any issue that you have on your network. Well, let me go ahead and now pass to the configuration section. Here we have a list of the devices. We have BH2K, BH1K, and well, etc. But what I want to highlight here is that you can change the mode of your device from CLI mode to vManage mode. If we use CLI mode, that's the traditional way to configure and manage your device. As you know, it would be a command line interface. But if you go to vManage mode and you choose this mode with any device, you're gonna have to attach a device template, which is nothing but a configuration template for this device, which is going to come with a bunch of feature templates for this device, and everything it's gonna be managed by the vManage. What means that if you go to the CLI of this device, of any device that is on vManage mode, it's going to refuse the commands because it's the only authority, the only entity that is that has permission to change any configuration of any device is the vManage, not the user on the CLI, right? In that way, you can attach one template to n number of devices. You can save a lot of hours of configuration. Okay, and in this section, in the controllers, you can see the vManage, the vSmart, the vBond, and the status. The status of these devices in sync, the certificate, and also change the mode of these devices. Let me go ahead and go to the certificates. In this part, you can monitor what's the status of your certificate, and once you install a certificate for any given device, you can send it to the controllers. And if you do the same to any given controller, you can send it to the vBond, so everything is well synchronized here. Let me pass to the template portion of this live demo. Here we have two kind of templates. We have device template and feature templates. The device template is nothing but a collection of feature templates. What is a feature template? A feature template is it could be a protocol, it could be an interface, it could be an SNMP, a banner. That could be a template. So pretty much you configure a feature template and you can invoke the feature template in your device template, and everything is going to be consolidated in that device template. And in consequence, the device template it's going to be pushed to any number of devices that you have in your network. For example, here I'm going to configure a VPN interface. Here we have to configure a template name that's mandatory, so I'm going to set SD-WAN webcast. And the description, it's going to be an example for the template, right? That's mandatory. And here we have a lot of things that we can configure only for a given VPN interface template. But what I want to show you is that we can either set an interface name, or we can configure a variable. Right, so I'm going to do this very quick. I'll save this feature template. We have this feature template here ready, and then I'm going to create a quick device template. Oh, this is worth to say that we can configure a GUI template and a CLI template. I'm going to show you what is a CLI template in just 1 minute. Okay, here we can choose any module of the devices that we have, going from ISR, C1000, ISR, B, and VHs. So here I'm going to choose VH Cloud. Okay, this is the device template, and here we can invoke any feature template that we have already configured on the vManage, right? But you can also use the factory template it's coming with the vManage as well. But here we are going to use the template that we have just configured. So for example, here we have the VPN 0. VPN is nothing but you can say that VPN is also a BRF, right? It's this pretty much the same terminology, the VPN and BRF. VPN 0, it could be what is known as the global table, and VPN 1, for example, it's gonna be a BRF 1. So you can easily understand what I'm talking about when I say VPN. So VPN, I'm under VPN 0, and I'm going to configure a VPN interface. And here is our feature template, SD-WAN webcast. I'm going to invoke this feature template here, and now it's here, right? We can also, if we had a VPN 512, would use the management VPN or any other templates to be invoked. We can also invoke any template here, a BFD template, AAA, OMP, security templates, BGP, and etc. So here I have my device template for the webinar, and we can attach a device here. Let me show you quickly. Once we attach a device, we can edit the template, and if we have configured any variable or any in the template, we can here configure whatever about the variable for any specific device. So, for example, for this system IP for this device, I'm going to say that okay, the description is a test template, right? And then you update the template, and it's gonna be pushed to this device. And it's the same history for any other devices that you have in your network. On this section of the policies, we have the centralized policy and the localized policy. In the localized policy, it's for a specific sites, for specific devices. The centralized policy is going to take effect on the whole network. On the localized policy, you can configure all of these parameters, and if you have, for example, a prefix list, you can configure a QoS map, a policy rewrite for this, and an access list or a route map for that is going to be used to manage your routing on your network. A routing policy can be the same as a route map or to manage or control the traffic of your network. But well, let me move to another tab here. Here is in this section of tools in the SSH terminal, you can access to any device and check the CLI of your device. Easily, everything is centralized in the vManage. So, for example, here I'm checking the VH Cloud, and let's say if I want to run show control connections, everything is going to be shown here, right? So you can also troubleshoot your device or configure your device, of course, if that device is in CLI mode, from here. And the last part that I'm going to show you is it's about the software upgrade. Here in the software upgrade section, you can choose and select one or everything to be upgraded. Everything from the vManage and the software repository is where you are going to store your software files that is going to be used when you perform an upgrade to any given device or any desired device. Okay, this was a very quick overview of how SD-WAN vManage looks like. I hope you have enjoyed this.
Oh, hi. Thank you very much, Juan, for this demonstration. Thank you very much, David and Charlie or Juan Rangel, for all the knowledge you have transferred here. Due to the time, we won't be able to read aloud many questions that we have from the audience, but most of them have been answered on the chat or in the Q&A. So could you please explain how this product competes with a Silver Peak and CloudGenix? We received in November this year report where Silver Peak is a leader in SD-WAN, and Cisco was downgraded as a challenger. So they would like to know, like, your opinion about this. So if you can please share it very quickly, we would kindly appreciate it, David or Juan and Charlie.
Well, I would say that the competition between both solutions, between any solution, will be based on stability, feature parity, and each one of the requirements you want to meet for some specific use case. If you need more about whatever Silver Peak is offering, I do apologize because I don't have all the information about it. But if they offer something specific that SD-WAN doesn't, then you would simply go for to pick their solution because it's meeting your requirements. Cisco, as far as I know, because of this, the Gartner report, they were downgraded because of, I do believe, rejudging the stability on the new set of devices that were rolled out, the new CHs. But again, this was after an acquisition, and there's a lot of ground to cover and many things to fix on the way there. So I do believe that this will change eventually, although, it's just that it recently happened. So, anyway, getting back to the topic, it depends on feature, stability, and availability of whatever the services you would need. So it's not only about how cute is the solution, but which requirements you're meeting to select it.
Thank you very much, David. And well, due to the time, once again, I will be closing down. So most of the question has been answered. And thank you very much for all of you who have bear with us again. I remind you that the recording of this session will be available in the upcoming days, most likely between Thursday and Friday. And well, thank you very much once again, the experts and everybody. If you have any further questions, we are going to have this session of Ask Me Anything form session available till December the 20th. You still have 1 week and a half to place all your related questions in this session, and the expert will be helping to clarify them, just as they have done during this session. Also, we would like to invite you to have a look to our social media channels. There you will find more information about the events, activities, and anything else that we are doing. Don't forget about the Helping Community special program that we're having. Let's help out to make this work better while helping the community. We're available on Twitter, Facebook, YouTube, the technical application for customers and partners, and on LinkedIn as well. Remember that we have different trainings and events and activities on different languages such as Spanish, Portuguese, Chinese, Japanese, Russian, and French, which is the latest community. And well, if you're looking for further IT training, have a look to all the sessions that the Cisco Learning Network organizes. They also can help you out to boost your career and all your knowledge regarding technology. Once again, thank you so much for your time. Please help us to fill a survey that is coming out just once the event's going to close down. It really helps us out to know where we can improve these sessions, and of course, what kind of topics you would like us to feature in upcoming events as well. For those who fill out this survey, you can redeem a 35% discount on any e-title the Cisco Press. Once again, thank you very much, David. It's always a pleasure. Juan, Rangel, and Juan Flores. This has been a great session, and it's the last of the year. We wish you all of you have great holidays.
Thanks, everybody. Had a blast here.
Happy holidays, everyone.
Thank you.
Thank you. So till the next session and till the next year.